Good morning, boys and girls. Let's begin with lesson 10 today. This is a quick review of both number sequences and scales as we commonly find them out and about in our world. First, let's begin with the term sequence. Following along in your book, we read that a sequence is an ordered list of numbers that follows a certain rule. And we have two quick examples. In example 1, we see 5, 10, 15, 20, 25, and so on. The rule that is being followed here is plus 5. Every time we move from the left to the right, we are going up by 5. We can continue to find terms in this addition sequence if we continue to add 5 to each number. Therefore, the following terms in this sequence would be 30, 35, 40, 45, and so on. Now, term B is a little bit different. Its rule, if we look at what's happening here, is 5 to 10 to 20 to 40 to 80. This is not an addition sequence, but a multiplication sequence. Every time we move from the left to the right, we are multiplying by 2. Therefore, the next term in this sequence will not be 80, but it will go to 160. Following that, if we multiply 160 times 2, our next term will be 320, and the next term would be 640. Therefore, sometimes our sequences follow an addition pattern, an addition rule, and sometimes we see a multiplication sequence. There are many other variations of sequences, and we will continue to look at some of those during the year. Down in example 1, we're asked, what is the next number in this sequence? Well, let's give it a quick look. We go from 1 to 3 to 9 to 27. We can pretty quickly see here that as we move from the left to the right, we are not adding an equal number each time. So let's consider that perhaps this is a multiplication sequence. And sure enough, knowing our multiples like we do, we see that as we go from 3 to 9 to 27, we are actually multiplying by 3 each time. 1 times 3 is 3 times 3 is 9. 9 times 3 is 27. Therefore, in order to find the next term in the sequence, we would take 27 times it by 3, and we would discover that the next term in this sequence is 81. Now, looking at the bottom of your page, we see that the numbers 0, 2, 4, 6, and 8 form a special sequence all made up of even numbers. We say the even numbers when we count by 2s. Please notice that 0 is not an even number. A whole number with the last digit of 0, 2, 4, 6, or 8, however, is an even number. 0 is nothing, therefore we don't consider 0 by itself an even number, but it is useful when we are trying to figure out if a larger number, say 420, is even. The last digit is 0. That does make it an even number. Now, we might also have sequences that are made up of odd numbers. Please remember that our odd numbers are 1, 3, 5, 7, 9, and any number ending in 1, 3, 5, 7, or 9 is also an odd number. With our odd numbers, we cannot evenly divide an odd number into two equal whole number groups. Let's look at example 2. Think of a whole number, any whole number, and then double it. Is it even or odd? Well, let's start with a whole number like 4. When we double it, it is 8, and that is definitely an even number. What happens if we start with an odd number? Let's try 7. When we double it, we come up with 14, and yes, it is also an even number. Therefore, the answer to example 2 is the answer is always even. Doubling any whole number, whether it's odd or even, results in an even number. Now let's move on and focus our attention just for a few minutes on the idea of scales. Scales are really just like number lines. They can be both horizontal or vertical. Numerical information is often presented to us in the form of a scale or a graph. A scale is a display of numbers with an indicator to show where a certain measure falls on the scale. I'm going to highlight that information. A scale is a display of numbers with an indicator to show where a certain measure falls on the scale. The next line is very important. You'll notice that it's in bold print. The trick to reading a scale is to discover the value of the marks on a scale. It's not always 1. Marks on a scale may show every unit, or only every 2 units, or 5 or 10, or sometimes even every 100. So the first thing we need to do when we look at a scale is to find the value of the units before we ever try to read the indicated number. So the first step, find unit value. And the second step will be to read. Let's look at a very common scale we often see, and it's our simple thermometer. Notice on this thermometer, to the left, we see temperatures recorded according to the Fahrenheit scale, and to the right, we see temperatures recorded to the Celsius scale. There are certain common temperature units I just need to have you memorize. The first is the boiling temperature of water. Following the Fahrenheit scale, it's 212 degrees Fahrenheit, and it is 100 degrees Celsius on the Celsius scale. Water boils at the same point. The only difference is whether we're using the Fahrenheit scale or the Celsius scale. Normal body temperature. Celsius is 37 degrees, Fahrenheit is 98.6. And the freezing temperature of water, 0 degrees Celsius and 32 degrees Fahrenheit. Please work to be sure you just have those numbers memorized. Now let's go on to example 3. We're asked what temperature is shown on the thermometer. Well, let's go back and remember our first step followed by our second step. The first step is to find out the value of each unit. Looking at the Fahrenheit scale, we see 0 here, we see 10 here. What we need to do to determine the value of each of these little units or spaces is to count the number of spaces we have. So let's count. 1, 2, 3, 4, 5. Each space represents, there are 5 spaces, okay? The range between 0 and 10 is 10 degrees. Therefore, if each little space, there are 5 spaces, 10 divided by 5 equals 2. So each little space must represent 2 degrees. We can go back and double check if we just simply count. We have 0, 2, 4, 6, 8, 10. I'm going to read what our book has printed out because I think they might say it a little bit more clearly than what I just muddled through. It says, as we look at the scale on this Fahrenheit thermometer, we see that the tick marks on the scale divide the distance from 0 to 10 degrees Fahrenheit into 5 equal sections. So, the number of degrees from one tick mark to the next tick mark must be 2 degrees. In other words, we take the range, 0 to 10 has a range of 10 degrees, divide it by the number of equal sections, 5, and we find the value of each section, 2 degrees. Now that we found the value of each section, we can read the indicated level. We see our thermometer stops here. Let's begin at 0 and count 2, 4, and our thermometer is marking or showing 4 degrees Fahrenheit. Would you please now do your lesson practice? In A and B, we're asked to find the next 3 numbers in the sequence. In C, you are asked to think of a whole number, double that number, then add 1. And will your final answer be even or odd? And in D, we see a thermometer with the temperature marked to the nearest degree Fahrenheit and Celsius. Notice this side of the thermometer is Fahrenheit, this is Celsius. Would you record this temperature both in Fahrenheit and Celsius degrees? Remember your steps. First, find the value of each section and then read the scale. Again, for D, you will record 2 temperatures.